This is the continuation of the basics of residential green rebuilding, brought to you by the Green Home Institute, a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. And a huge thanks to our sponsors, Anderson Windows and Panasonic, along with our members and volunteers and board who allow us to do these sessions. The entire series modules will be covering each of the 5 pillars of green: materials, energy, health, water, and place. This is module 2, and we'll be covering energy. In other terms, other programs that you might look at, you might hear the terms energy and atmosphere, energy conservation, energy efficiency, or Energy Star, but we'll be referring directly to the term energy to be synonymous with many of these other terms that you may hear in other programs. So real quick, the residential and building industry has a huge impact on our energy efficiency, and so therefore we have or on our energy usage as far as consumption goes, and so we have a huge opportunity to make reductions. In the residential side, we understand that people who pay more for energy due to energy efficient housing have a higher risk of mortgage default. And so by incorporating energy efficiency, we can help remove those issues and prevent those barriers. Other things that we're seeing is simply by disclosing your energy usage. So working with your clients to help them just disclose their energy usage during a home sale process, not whether it's even good or bad, just having that transparency can increase resale value in less time on the market. So imagine if it's proven to be better than the average project. And then overall, looking at the Green and Healthier Homes report by McGraw-Hill that just came out, we can see in the top 10 most green product practices as a percentage of builders and remodelers surveyed, you can see the first one has to do with energy, properly sized, installed HVAC systems. Third one, again, HVAC, water heating, insulation, appliances, windows, and then going down to lighting. So energy plays a huge role in being some of the first things that people look at in regards to the other 4 green certification or green building components, green pillars, if you will. So when it comes to energy, what we base off is the energy efficiency pyramid. And this can be applied to new construction just as it is applied to working with your clients on renovations, additions, and rehabs. And so we use this as a good practice, a good way to get started, looking at the very bottom of the pyramid as some very simple things. Some of the things can be done directly by homeowners and your clients, all the way up to the more complex, complicated things that require more cost, more professional labor, but also have higher paybacks. The ones on the bottom of the pyramid have small but quicker paybacks. And so using this pyramid, let's start at the bottom and work our way up. So the first thing we're going to look at is understanding. And understanding is really looking at the idea of knowing how much energy a home is using or could be using when it's built new. We look at things like smart meters, energy use intensity, EUI, which is basically energy per year per square foot. We look at tools like the Home Energy Saver, which is a easy, simple tool that was designed for professionals or homeowners to make energy efficiency design decisions. More formal tools such as the Home Energy Score and Home Energy Rating Score we'll cover, as well as, especially for new construction projects, the concept of using passive solar design and understanding how your project fits on the lot and can work with the sun as opposed to against the sun. So the very first thing, if you're working with clients, you can work with them to go around their house and take an assessment of how much energy their devices are using and find a lot of savings simply by just cutting out some of those devices that are always plugged in or drawing vampire power using devices like this. You could work with them on using a total seasonal energy use calculation for gas and electricity. And especially if it's for an existing home, you can look at how much energy they're using both in gas and electric, even if they've got propane or wood. There are tools to do this. And then you can look at their square footage and get an estimate of what their total EUI is, and then how much work they need to do depending on what goal they want to hit. Now, this doesn't tell you why they're doing poorly or where they're doing poorly at, but at least it's a simple tool to say if their home potentially has a lot of opportunity to improve. Again, going a little more in depth is the Home Energy Saver. It's an online free tool by the Department of Energy and NREL, and this is a great tool both for do-it-yourself homeowners or you as the contractor to go through the professional side of things and again get some good guidance on what you can do to make improvements both in existing homes or to run your plans through it on your new construction project. Going a little further, the Department of Energy new Home Energy Score. This is a label that's given by a professional who's trained and licensed to deliver energy efficiency. And this score is derived based on algorithms, and based on our research has been fairly accurate compared to utility usage, and gives the homeowner both a 1 through 10 label that tells them how well their house is doing, and then you as a contractor can either develop one of these or work with an independent rater to put together a scope of work and plan to help the homeowner move to the next level and utilize your services for energy efficiency. This tool can also be used for new construction single-family home to guide design and implementation, as well as inspections during the pre-drywall and final process. So again, a home will get an initial score, and then you as a contractor can give a scope of work and let the homeowner know where their house will come in at, how much energy and money they'll save by doing that, and really put together a well-detailed plan that gives the home an understanding of what energy it's using. The interesting thing about this score is it just tells how homes are being compared to the rest of the community, the rest of the country. So you can see homes in the 1 range are in the 15th percentile. Homes in the 5 range are about 50% of the existing homes out there. And then homes in the 10 are in the 90% percentile, so few and far between as far as what this score means in the marketplace. Now, the Home Energy Rating System, or HERS Index, is probably one of the more popular rating scores. This has been around for quite some time and is now being used on a third of all single-family new construction, major renovations, as well as up to 3-story low-rise multifamily housing projects. And this score basically works on a 100 scale, meaning it's built to the average code across all the states, varying depending on the state code. And then with every drop, you have a 1% increase in efficiency all the way down to 0, which is 0 energy. So this tool is really designed for new construction. It has a third-party quality assurance piece in place, and it has a network of raters around the country to help you on your next project. Come in and model your project, get you to the score that you want to be at, either based on your goals, your client's goals, as far as how much they want to spend on their energy bill, how to meet the code. A lot of codes will allow this to be used as a way to meet the code. And it's a tool that, the rater comes in and does a quality assurance inspection during the pre-drywall and then final stages, and then helps ensure that the energy efficiency of the project was done right. So this is a pretty neat tool, and we're going to have a ton more education on how to utilize it. So again, perfect time when you're designing a new home to think about the orientation of that house, how much south-facing window glazing there is, east and west and north, how much shading there is, depending on the summer or winter time. There's lots of design programs that can help you figure this out, but these are some things that get missed a lot of times ultimately we usually see homes designed to work against the sun that are overheating in the winter and not taking advantage of free passive solar overheating in the summer and not taking advantage of the free passive solar in the wintertime. So there are guidance and tools out there, design tools out there that can help you make sure you take advantage of this. And if you're doing a major renovation, you might have the opportunity to move windows around and increase awnings and try to do this for a project, which again can completely increase the comfort and natural lighting of a home. So again, here's just a model of having proper design, especially up. Now these change a little bit depending on the climate zone you're in. You'd have a different situation down in Florida. But again, the whole idea is to keep the direct sun out, indirect light come in, and then get the direct sun in especially in the cold weather climates during the wintertime, so that it does heat up the house. And again, there are opportunities to use things like thermal mass, like concrete or clay or straw bale, that it can absorb the heat that's coming in during the winter in the cold weather climates, and then release it at night for some free heating. So take advantage of that as well. All right, moving on from just again having understanding to low cost or no cost improvements that can be done on the energy efficiency pyramid. So again, working with your clients to, one of the first things that they can do to get their energy bill down is simply unplug things that are drawing energy but don't need to be when they're not in use. And so having a power management plan for your client or for your client's tenants, especially in multifamily housing, can be very important. Utilizing things like the smart strips can help save your clients a lot of money, and these kinds of things can actually be built right into the walls if you've got savvy electricians. Making sure your clients are speccing Energy Star appliances. If you're helping purchase appliances for them, making sure that you're speccing all Energy Star, which is difficult to not come across these days. LED TVs, make a huge impact and reduction. Even going so far as to working with your clients to, do energy management on their computer software. And one thing people don't realize is that fans can also get Energy Star certification on them and also save a lot of energy. So again, speccing those fans in there, making sure there's LED lighting in the fans. And then, of course, it's up to your clients to make sure to not keep those on when they're not in the room, because they do not cool rooms down. Also using integrated smart thermostat features. There are many thermostats out there that can learn behaviors of your client and help them keep the energy down. There are thermostats out there that can detect when they're getting close, if they're off of their normal traveling schedule, and then it will detect that they're coming close to the home, and then ramp the home's temperature up to a more comfortable level. Because again, we're not asking anyone to be uncomfortable during this, but having smart thermostats that can be programmed and having those built right into the system is very important. Here's a simple thing you can do for your client is get some pipe wrap. Sometimes utilities provide this for free or offset the cost. And at least wrap the first 10 feet of the hot water piping, whether it be copper or PEX tubing. That can save a lot of energy as well, especially for long pipe runs. And then again, working with your clients to seal up and tighten their doors. We see a lot of doors out there that you get the light leaking into it, that are unsealed. And so this is a great opportunity, especially if you're in the existing homes market, to go in and check your client's doors, check for leaks and cracks, and then just offer that as part of your scope of work to seal that up. And then also ducts, very low-hanging fruit here, especially during the new construction process when ducts aren't hidden behind the walls. You definitely want to get these sealed up. Either you can see with a metal tape, or you can use we recommend a low or no VOC mastic that you can paint on all the joints. Make sure to get all those sealed up before the drywall goes up, otherwise it's very expensive to fix. And then for existing homes, you can help seal the ducts of your clients where you can see that. And one of the things I can do, depending on if the ducts are in interior space or not, and again, we highly recommend the ducts stay in interior space, but that can actually, a lot of times it may not reduce energy usage, but it does highly improve comfort, especially if there's like an unheated basement that's not meant to be heated, and you can help seal those ducts up. You can essentially improve the airflow to the rooms that need it. So those are really easy things. A lot of those things your clients, might be able to do on their own, but may determine to hire you for it. So let's kind of move into this next one, which is going to be lighting, as far as low-hanging fruit. On the top, it's LEDs, light-emitting diodes, and then over to the right is CFLs, and then way to the right is incandescents. And this just goes to show that you're going to go from an incandescent to go from an incandescent to a CFL is a major jump in energy reduction, a huge instant savings right away. But if your clients have all CFLs and you're trying to take them from CFLs to LEDs, there's not going to be too much savings there. And so, there's other strategies to come up with, such as taking out the CFLs out of the high-use rooms and putting the LEDs in the high-use rooms. That might be one strategy to do. And again, clients will pay for, especially in existing homes, even for you to come in and provide all of the light bulbs and swap them out. If they have all incandescents, then we highly recommend going straight to LEDs, which are coming way down in energy usage. Other questions: how many bulbs are on a single switch? So if a client turns on a light, how many lights does it turn on? Is it too many? And so should it be rewired? We do see a lot of rooms that are just overlit, and so lots of opportunities to change out the lighting fixture, because people see all of the fixtures and they just need to fill them all. So, then rooms tend to get overlit, and that can cause health issues, not only that, but waste energy. And then getting dimmable lights, which can save a lot of energy, as well as, improve the ambience of a room, considering both photo sensors, and then working with your clients to install motion sensors. So this idea that we walk out of a room, we accidentally leave the light on, and it's wasting your client's money. This is the point where you want to consider working with them to weed that out and install motion sensors. And then night lights. Again, there's really cheap LED night lights out there that are also motion and photo sensors that can be installed or integrated right into existing wall structures, or now integrated right into the plug, and then kind of reduce the harsh lighting at night when your clients need it. This kind of gets more into the next module of health, but I want to cover it here since we're talking about lighting. And this has to do with our circadian system, and so what we see is typically CFL bulbs. The type of lighting they put out can cause headaches, strain, can fade furniture, and then also another caveat of them: if they do get broken, they will expose your clients to mercury, which can be concerning. So LEDs, while they do have their issues as well, they are being more designed for healthier light waves. And so that's another thing to consider, depending on how your clients are using their spaces. And if they're going to have a lot of lighting on, it may be important to consider the type of lighting that you put in for health perspectives, as well as the fact that if an LED breaks, it's not going to put mercury into the air. Now, going outdoors, what's interesting is this new association called the International Dark Sky Association, and they have approved concepts for fixtures that prevent you from your clients wasting their energy by lighting up the night sky. So a lot of light gets aimed up, and so number one, this is wasting energy. Number two, it can disrupt migratory bird patterns, And number three, you know, the worst effect is that if you look at our cities now, we no longer can see the Milky Way. We can no longer see the cosmos at night, which has been led to believe that it may have an impact on our health and well-being. So we can imagine a world one day where our streets are well lit, but we can still look up and see a majority of the stars. You know, I like to imagine that future, while saving energy and money at the same time. So you can take a look at that for recommendations on helping your clients improve their outdoor lighting needs, and also consider the fact that outdoor lighting actually can lead to more safety issues because you're actually lighting the way for people who may have ill intent. By keeping it dark, they actually can't see anything. And so there have been studies showing that perhaps having no lighting at all would be an impediment to crime, and lighting perhaps is helping it. So moving on, and that arrow didn't go up there, but attics, walls, foundation, insulation is next on the list for complexity and investment on our energy efficiency pyramid. I'm sorry, air sealing. Air sealing is our next one. And especially in the cold weather climate states, air sealing is huge. Most of the energy lost in cold weather climate states especially, but even in warmer states, warmer areas, is due to convection and movement of air. Also, this leads to discomfort. So finding where all those holes are. I showed you some of those energy during the understanding section there, energy performance tools. Well, a lot of folks will work with a rater or purchase and use in-house a blower door test. And so what a blower door test will do is to pressurize a building and help you go in and easily spot where all of these holes are. I mean, some of them you might be able to see with your eyes, but easily spot these holes both during the renovation or prior to the renovation process to give you a plan, and then also during the pre-drywall stage on a new construction project, and then be able to give you a plan to make sure to seal those up before the job is done. Again, honing in on some existing attics, tons and tons of air leaks up there, and again, depending on where you're at, there are different housing types, and you want to have that local knowledge of what kind of housing types typically have what kind of air leakages in them, so you have a good understanding of how to go in and find those and seal those up. Again, so some of the strategies out there, using two-part spray foam to seal up the cracks and leaks, especially in the attics, and rim band joists where basements come together is a way to both seal and insulate a building. There's also things out there that are a little less, shall we say, a little more healthy, and don't necessarily rely on oil like spray foam does, which has a contingent of oil. And so using other things behind the walls, there's other sealants out there besides conventional spray foam. And so here's just an image again of a rim band joist in the basement, most likely using closed cell foam, which is also going to help keep moisture out of the area. So that's very important, as well as keeping air loss and heat loss from coming in through that space, which is usually the second most leakiest and energy loss, especially in cold weather climate places with basements. Other things you can do, these are kind of low-hanging fruit, but you can work with your client to gasket and seal their baseboards, especially on an existing home. If you don't want to tear out the baseboards, you can just seal on all the edges and seal up the windows. You can go ahead and gasket outlets if you want to swap them out, or just foam right behind them as another way to seal up leaks. And then encourage your clients to put plugs on their electrical outlets. Number one, if they have children, this is a 2-for-1 on the exterior plugs anyway, because what it does is it keeps children out of the plugs, but then keeps air leakage directly from coming into the house, which usually comes through plugs from uninsulated or unair sealed walls. And so here's a lead project in Illinois where the volunteers got very excited and did a phenomenal caulk job. And so, caulk is a pretty cheap substance, pretty easy to install, doesn't require ventilation. Just a little more labor though, but a good opportunity, especially using no VOC or low VOC caulk to caulk up all the penetrations and joints in new and existing homes. So moving on from air sealing, we're going to take a quick break with that concept and then jump into the next area of the energy efficiency pyramid, which is the appliances. And these are pretty straightforward. Again, help if you're doing purchases for your clients or encouraging them. First of all, the easiest thing they can do is purchase ENERGY STAR certified products, and there are different tier ratings, 1 through 3 or CE ratings. So I believe the 3 rating is the higher level of that. So look for those. Some other interesting things here. Take a look at these refrigerators here. You see on the left, you've got side by side. You've got a unit with a freezer on the top, and then a user with a freezer on the bottom. And just pause the recording for a second and think to yourself, which one of these are going to waste more of your client's money. And so think about that for a second. And so if you answered the one on the left, the side by side, you would be right. Even if this is an ENERGY STAR certified refrigerator, the side by side models use way more energy than the bottom up or top down. Both the bottom up and the freezer down are highly recommended for energy efficiency purposes. And so, consider that when you're putting an energy plan together and, making purchases with your clients. Dryer technology has come a long way. So now dryers, prior to a year or so ago, you didn't have ENERGY STAR certified dryers, but now you can get an ENERGY STAR certified dryer. So again, ENERGY STAR certified means it was tested and inspected by the federal government to meet, low energy usage. So that's one concept. The other is the other 2 concepts here. First, I just want to note are going to be very helpful because what they're going to do is plug one more hole in the house that doesn't need to be there. Remember, in our last part of the pyramid, air sealing is important. So if dryers have to be vented to the outside and ideally vented 10 feet away from any air intakes, very important. But that vent is, another air loss and another heat loss in the house. And so these 2 types down here, heat pumps and condensing dryers, eliminate that need for a vent. Because what a heat pump dryer does is it essentially takes in the indoor temperature and uses heat pump technology and electricity to turn that heat into and heat the dryer and then condense the water. And then same for a condensing unit, a little less efficient than a heat pump, depending on where you've placed your heat pump dryer. If it's in a really cold basement, it may be inefficient. But a condensing unit, and I've had one of these for quite a while and they work great, it's just basically going to condense the water. It's going to be very efficient, especially if you pair it with especially if your client pairs it with a really high spin cycle on their washer. And that will just, instead of venting it, it'll just put the water right into the same sink. Another thing you can work with your client on is considering induction stove. So one thing to note that gas stoves typically use a lot less energy than electric. And if you're someone who likes to cook a lot, most cooks prefer gas over electric. I know I do. But actually, induction stoves, from a cooking standpoint, have a lot of praise from high-level chefs. But not only that, but take a look at this bottom picture. What induction basically doing is sending energy through magnetism through certain substances. So you can touch that stove there, and it won't be hot because it's only heating the element. And so what you have with gas stoves is just a lot of waste heat. Try to leave, something solid like coconut oil next to your stove. It'll melt it on a gas stove. And what electric resistance just uses a lot of energy. It's a huge waste of energy. So induction's all electric. And some other benefits of that is you don't have to vent it. You don't have carbon monoxide issues. And then again, it's just super energy efficient. And so again, if you're helping with your client, we've got builders that are speccing these and working with their clients to again reduce their energy and make their home healthier with these types of applications. All right, so we moved, into insulation, and we're just going to cover insulation in this session and not necessarily ventilation. But I will get into why, once you've gotten past air sealing and insulation, which you typically do at the same time with your clients, why the ventilation will then be important in the next module. So the first thing to know about insulation is that it's not, the inches of it are not all created equal. So R38 is our code up here in Michigan for a standard roof. So R is resistance to heat. And so you can just see how many inches of fiberglass it takes to get there versus how many inches of cellulose versus how many inches of spray foam. So that tells you right there, depending on your wall cavities and your cavities up in the attic, how much room you're dealing with and how much room you're going to need to get insulation filled in there, depending on what your strategy is. So first things first, up in the attic, very important. So after you've laid down that air seal, you can blow in something like cellulose on top of that, which can help keep costs down. Typically, cellulose is pretty cheap. It's made out of recycled material, and it's a lot easier to install than fiberglass. So this is just a blow-in method, and this can be blown into the walls, into the attic, both for new and existing homes, and that's definitely a service you can offer your clients. There are other things like going down into the rim band joist. Again, if you don't want to use all foam for certain reasons, you can air seal the edges, and then you can install something like a rigid rock wool or a rigid foam board, or even now they make, in certain markets, a rigid cellulose made of all recycled materials that can be installed. Just cut right out. You can cut it right out for your clients and install it right in there. And so here's the drill and fill opportunity here. And this is where you're going to have to work with your client on the existing homes and try to determine what's the best method to get in behind the walls with either cellulose. You can use blown in fiberglass to get behind the walls, and you can drill in from the inside and then just patch up the drywall, or you can pop off the siding, or you may have to drill into the siding and then patch it up out there as well. The only thing I do caution about this is when you start putting insulation into walls that used to just allow the temperature to fluctuate, now you've got more warm air being trapped in that wall, which can lead to moisture and maybe mold issues. Now, typically these cellulose applications come with mold inhibitors, but that is something to be considered about and something we'll cover as well. Take a look on the left here. This is now they have these foam applications where you can actually foam in between the walls. And so on the left here is a house that had cellulose in it that was poorly insulated, and they used the foam to seal in between it. In the middle, there's a house with fiberglass here. You can see a little thing on the bottom right. And so, again, the foam was able to get in there and fill the cracks up between the fiberglass. And then on the right was just a pure empty cavity. And again, foam could go in there to both air seal and insulate right behind the wall. And then again, for new construction, you definitely have a really great opportunity here for insulation of the exterior wall, or what is also being called now outsolation. And in fact, we're seeing a lot of people argue that outsolation and not doing any interior insulation is the way to go for many different reasons if done right, both to keep heat in the winter, heat out in the summer, and to protect against moisture and water. So there's lots of different things out there. A lot of people use a foam board, like 1 to 2 inches on an existing home. If you use, more than 2 inches, you might have to, move the windows out a little bit. You can also, there's also rock wool now that's made out of spun natural rock that's rated, fire rated, and moisture rated, as well as permeable. To let water pass through it, that's highly insulative, and you can use that on the exterior walls. And so again, if you're working with an existing home and the client is planning on taking their siding off, this is a great time to look behind here and insulate it. If they're not planning on taking their siding off, it could be a little bit of an expensive endeavor. But it might be a little more safe if you do need to insulate the walls to meet their energy goals, a little bit more safe than doing a drill and fill cellulose application, assuming you get the, you get everything right on there to keep the water out. And so when you're doing framing or you have an opportunity to, stud out new spaces in homes for additions, you want to consider going to the bottom one here with 24-inch on center for the stud spacing, as well as California corners and some other applications with a single top plate. Number one, we're kind of getting into the materials pillar here, but you essentially reducing demand for wood, which reduces strain on our forests. But then also you can get more insulation fit in between these studs, which then leads to a more energy efficient and comfortable home. And then also what thermal bridging does, or what this wood is doing, or if you're using steel studs, is it's doing massive thermal bridging. So it's just conducting a lot of heat from the drywall or plaster, and it's going right out the house. So you could theoretically do 12 inches on center, but then you would want to put an outside exterior application like we just shown you back there to prevent that thermal bridging from happening. Here it's going to happen a lot less if you're not doing the outsolation. Another thing to consider that I don't have listed here is going from 2x4s to 2x6s, because again, you can then fit even more inches, R value, of insulation behind those walls. And so these are some very simple things. They require a little bit of changes to the plans, but if you haven't started your plans yet, this is a great time to implement this because, again, once you get your plans going and your products going, it can be tough to, make change orders. So, going down both either into the basement or into interior studded walls. From the inside, there are, like I showed you in the rim band joist there are all sorts of applications for rigid. Here's a rigid cellulose, which is pretty unique to the market, that could be fit right into studs. Down in the basement, I actually had it on my former house that I sold, and people went down there, and it wasn't studded in, it was just glued right up to the old wall. It was a 1928-year-old home. And so everyone thought that it was cement still. They couldn't tell the difference. And then they touched it and saw that it was bouncy. And so that was, kind of funny. But anyway, you can get rock wool for these applications, and you can get rigid rock wool for exterior grade insulation, or you can get and cut out foam board, which is going to have a little more resistance to heat value. But again, it's made out of foam and can be a little more costly. So getting under the slab can be very difficult unless you're planning a major rehab and planning on busting up the slab. And there's other reasons you might want to do that, from both reducing moisture issues, to preventing radon, which we'll get into in the next session modules. So on an existing home, it's not something that's too doable, and a lot of programs that require slab insulation or codes allow you to avoid that slab insulation if you're pulling permits or doing a green program for existing homes. But if you're doing a new project, this is something you definitely don't want to miss. You want to get your slab insulation done right. I have heard of non-foam products like foam glass or like rigid rock wool that are approved for underground slab insulation. Again, if your clients for whatever reason don't want to use foam. But again, this is one of the least places that heat escapes into the ground, but huge impact on energy bills if you can get in there on new construction projects. All right, so let's look at water heating now. So on existing homes, one thing to take a look at for your clients And if you working with a rater, they can do something called combustion analyzation. And so if you've got an older water heater, an older tank one, there is an opportunity that it could be leaking carbon monoxide, could be backdrafting into the house if someone turns on their bath fan or their kitchen hood range. And so it could cause all sorts of health issues, as well as pulling moisture into the home and causing moisture problems. So the biggest reason you would want to replace one of these isn't really necessarily for energy efficiency, but mostly for your client's health, especially if you're following the other aspects of the pyramid and sealing the house up. So if you do decide to replace it, great. If you're stuck in a new project, I'm going to tell you right away, do not order a naturally drafting water heater. It's a very bad idea, very inefficient, and again, can lead to health issues for your client down the road. So what should you do? Basic Energy Star, sealed combustion or power vented water heater. Look for 0.8 or greater. And a lot of these are tied to energy efficiency incentives. So again, these just draw in outdoor air, and then they exhaust the the more toxic air and prevent some of those issues. Of course, all on-demand tankless are going to be sealed combustion. And again, these units can be a little more efficient for your clients. Could also provide a revenue stream because they do need to be cleaned out, flushed out. And so if it's something that your clients don't want to do, or it's a hassle, there's a service you can provide. And these tend to be pretty efficient unless people are taking infinitely long showers, and then they're actually a lot less efficient and have been found to be maybe not the greatest thing in the world. Other new things that are coming out, heat pump technology for water heaters. So again, depending on if you've got a nice sealed basement that doesn't get too cold, you can use a device like this for your client, work with them to do this. It doesn't require any outdoor air, so again, it's also sealing up another leak in the house, and then uses the natural heating of the air to use electricity to heat up the water. The other thing you can help your clients with, whether new or an existing home, is centralizing the water heater to reduce the runs. So that will also reduce the amount of heat loss through the runs, through the pipe runs of the house, so getting it closer to all of the applications. If you're not using a centralized water heater, one way you can do that is to use decentralized point source water heaters. They have them both in electric and gas, so we highly recommend electric. This is clearly something that's really popular in Germany and in Europe, as well as in California. But it is growing in popularity, and some of the benefits that it does offer is, number one, if there is a failure that occurs on the water heater, then at least it only occurs in one of these units and not all three or four of them. So that's good news, and so you still have hot water in some applications versus the other. Plus their costs are pretty minimal. PEX piping. People ask what's better, PEX or copper. From an energy efficiency standpoint, PEX is going to give off a lot less heat. It's also a lot cheaper, but I do warn that there are some inconclusive studies in regards to the plasticizers out there that come out of PEX piping, whereas in copper, it actually is antimicrobial, and so is typically going to be a much healthier water flow rate. But copper is very energy inefficient, so definitely, like we said before, help your clients seal that up. All right, moving on to the next biggest investment. And so this one thing, I do want to stop here and just make a point on this, and that is that we typically see we typically see this pyramid flipped on its head. Well, really bad if it's flipped on its head, but remove the top part there and then flip it on its head, and those are the things. That's the order you see people with their projects in, and do them very slowly with their contractors over time, and that can lead to a whole host of problems by flipping this pyramid on its head. And actually, some people do renewables first, which is actually not a good idea for your pocketbook. But we see people flip this on its head, and so we really do stress when you're working with your clients to keep this in perspective for them, because flipping this on its head can lead to other health and safety issues in the home. So the first thing is, what tends to happen is that the heating and cooling systems are typically always installed oversized, and the reason that might be is because the HVAC contractor makes a little bit more money by selling a bigger unit. But then really what happens is they just want, they want to make sure it's sized enough so that during the extreme days of heating and cooling, the units don't fail to heat and cool the house. So that's fair enough. That's a fair enough assessment or argument. But the problem with some of these oversized units that in this case have improper ducting is that they really can significantly reduce comfort, and the systems fire up, shut off, fire up, shut off, and that can lead to reduction in durability and life longevity of your client's system. And then especially if they have if they did insulation and air sealing and then didn't change out their heating and cooling system, well, then it could be even more oversized and cause more problems in the house. So that's something very important to consider, and you'd want to look at something like doing a manual J or D with the HVAC contractor to get the sizing right, and that can be based on the scope of work and the plan. So if you're working with your client to do a big project, you can say, look, if we air seal and insulate the house and then redo the windows potentially, it's going to reduce the demand based on this calculation, and work with the HVAC contractor to make sure that they purchase the right size system, rather than just sort of approaching it kind of blinded and not knowing what way to go. So one thing we also see, even in new homes still, is folks panning the ducts into the joist. So right there you've got several problems. You've got energy loss, which is going to lead to comfort loss because that's going to lead to really hyper leaky ducts. It's going to lead to moisture problems and potentially mold problems when you've got moisture being pulled out by the AC and then having it hit the wood and then rot the wood. So if you're working on a new home, definitely something you want to avoid. If you're working on an existing home, highly recommend coming up with a plan to unpan the joist ducts and get them out of there prior to, along with the scope of work that you provide to your client. And then the other thing, again, to look at is considering keeping ducts out of unconditioned space. So like up here you can see at the top, you've got a system that is in unconditioned space above the insulation, so hemorrhaging energy, and the ducts are in the unconditioned space. And then, of course, also paying attention to how airtight your ducts are and sealed. And similar to a blower door test we talked about, there are tools out there that can, called a bolometer, that can actually test duct leakiness and, give you an idea on what's going on, so you can, again, seal those ducts up before they get closed behind the walls. Now, if you're working with an existing home client and you determine that they want to get the ducts sealed as part of the scope of work, there are products out there that can be integrated right into the system if the ducts are behind the wall and you can't get all of them, and then they can seal the ducts from the inside, which again can help improve comfort and reduce other issues in the house. So also, when you're going into a project, look for asbestos. Make sure the energy rater you're working with should be trained to not do a blower door test while there's asbestos. That can cause all sorts of issues. Shake it loose, get into the house, and it is directly connected to cancer and other issues. So this is an opportunity to look for that asbestos, and then work with your client to swap out the duct boot to make their house a little bit healthier while you're redoing their ducting system. So when it comes to furnace efficiency, these are really simple things, and a lot of our rating tools can help you determine just based on how old the furnace is if you can't find its efficiency where it's at. You know, one thing that, one thing to note is if you see a naturally drafting furnace, you can already determine that it's probably only 80% efficient, because once you're getting it up into the 90 realm, you are going to have a sealed combustion furnace. And so again, just like hot water heaters, naturally drafting furnaces can put moisture, carbon monoxide, and other other pollutants into the house. And so working with your client to get them a sealed combustion furnace can be really important. You know, when it comes to air conditioning, you would look at the seasonal energy efficiency ratio, the SEER rating on there, and whether the AC is Energy Star certified. Typically, we see 16 as sort of the sweet spot. You know, that's really good up in the cold climates who don't get as much of a cooling season, and then, you know, may not be as good getting down into the warmer climates. So, you know, somewhere within that 13 to 20 range, depending on where your project is. And again, you probably want to look at the rebates available as well. And just like the furnace, you want to make sure that this thing is properly sized. Having an oversized AC that shuts off, fires up, shuts off, fires off, shuts off, is not going to draw humidity out of the house as well. And so this can also serve as a dehumidifier, as a 2-for-1, if it's properly sized. Otherwise, you know, it won't do much help in that regard. So. Some unique systems, geothermal. A lot of people believe geothermal is a renewable energy. If you're using it for electrical source at a power plant, it is. But in the cases of homes, all it is a energy efficiency strategy that takes the natural heating, cooling temperature of the earth, uses some piping underground, and then uses a heat pump to distribute the air around the house, either through ducts or through piping. And you can get a superheater and also use this for the hot water heater for your clients, for the water heater. There's tax credits associated with this, and projects that are in more urban areas, we're starting to see folks, the costs come down on actually drilling down into the ground and allowing people to have these systems geothermal, which is, again, contingent on electricity and very energy efficient. If your clients still want to use heat pumps but don't like the cost of geo, or maybe the ground isn't right for it, or they're too close, they can use air source or air to water source heat pumps. They can use systems like ductless mini splits, which can be placed strategically around the house to individually heat and cool every single zone or room in the house. You see these a lot in commercial buildings. And one of the biggest complaints about them is they're just these ugly things on the wall. And so lots of different folks and lots of different companies are coming up with strategies to essentially hide these systems and make your client's house look a lot better. You can also use integrated heat pumps that get integrated right into existing duct systems, and that can be new or existing duct systems, and then it will function just like an AC unit, air handler outside. Again, to warn about these is that they're, depending on the model you get, they can be rated down to 13 to negative 20 degrees. But on some of those worst case scenarios in the Twin Cities or Traverse City, Michigan, you know, they may need some sort of backup element, and they then may not be as desirable as geothermal, you know, which isn't going to be impacted by some of those colder days. The other thing about heat pumps is they lose their energy efficiency rating when it's colder, so they're not as efficient. So that's something to consider too if your client wants to spec those things. So, all right, moving on to the last part of the structure. Again, you see it everywhere. Change your windows, reduce your energy by 50%. It's just crazy. But windows are one, I mean, unless you've got holes in your windows, they're one of the least places that can improve energy efficiency, especially for the cost associated with them. So, you know, your clients are going to say, let's get the windows, and you want to tell them that is the last thing we want to focus on. Let's get all of these other aspects right to get your energy down, and then let's look at the windows, which have other applications or other reasons to look at other than just energy, of course. We understand that. So the first thing is you know, if you're working with an existing homes client, especially in if you've got older homes, older wood windows, you know, there's a lot of merit to restore those and to be able to have the skill set to restore those. And there's lots of resources online on how to do that, but we highly encourage you to consider a restoration, air sealing, insulating the interiors of the windows. We have some extra training on how and why to do that. And so you can really help save your client a lot of money, help get them some really nice older looking windows to retain the character of the home, and they're, you know, nearly just as efficient as a new window. The other thing you can do, and that's what we did, is restore our old windows, and then we added low-E storm windows, made right here in America. And these have a coating in them that can help keep heat out, can help reflect light if necessary, and you can add the storm window to the exterior of the existing older window, again, to just complete the energy efficiency retrofit. If you are going to do new windows, again, here's a time to consider if you're using a passive solar design strategy. Here's the time to look at what they call the U factor, which is the inverse of the R value. So R value, resistance to heat, you want to have a higher number. For U factor, you want to have a lower number. And then you also want to look at things like solar heat gain coefficient, and those numbers are useful depending on where you're placing your window, and also depending on what climate zone you're in, because you know in certain zones they might have no value because most of the time of the year you actually want heat from the sun coming into your window rather than being reflected out. In southern climates, you want it to be reflected out, and then again also depending on where the window is located. On the north side of a home, in the north, it's not going to be as useful to have a higher solar heat gain coefficient than it maybe is on the south side. Other things to consider, so you've got things like wood windows, which aren't that efficient. Then you've got PVC windows, which are hyper efficient. But we'll get into the materials module next. Perhaps you want to consider the fact of the life cycle analysis and what PVC is made out of, and then maybe want to look at the concept of a fiberglass window, which is going to have a little less impact environmentally, but is just as energy efficient and, quite honestly, probably a lot nicer looking, than some PVC windows out there, again, depending on what your clients are looking for. And then as far as fenestrations go, again, if you are helping tighten your door up or swapping a door out for your client or speccing a door, you can look for Energy Star certified doors with fiberglass cores in them. Obviously, trying to keep windows out of doors is going to also make them, a lot more energy efficient. All right. So last but not least, few and far between we see this, but sometimes we do see project teams, want to go straight to the renewables. Renewables are very sexy. You can see them. Your clients get excited about them if they're green clients. And, some of the air sealing stuff and the insulation, which has clearly the most bang for your buck and impact, isn't that cool? You can't see it. You can't show it off. So we do see people, tell me about the solar, tell me about that. And so we do, again, the energy efficiency pyramid to help put this in perspective. No matter what you do, this is going to cost a lot of money, and it's not going to save as much energy, though it does give you super cool green points. But, make sure to detail that, with your clients there. So I do want to mention that I will be focused on solar. The thing about wind, which is the other biggest renewable, is it doesn't really work well on small scale. If you're near a lake on a big farm, large-scale wind, larger, taller wind makes some sense. But solar is going to work everywhere because everywhere the sun is going to hit. So that's one thing to keep in mind. There's also the idea of biofuels, and there's also the idea of using wood stoves to heat a house or heat and cool a house, wood stove generators, depending on if the forest is if it's sustainably harvested from the forest, and that can get into all sorts of things. And then there's the idea of small hydro. So if you've got a small creek, you could have a client that might be, and we've had a lot of these questions like, can I harvest that running water with like a small, almost like wind turbine, but in the water? So we're not going to focus on some of those. We're going to focus more on the concept of solar. And let's start with solar thermal. What solar thermal is it's basically a square that's put up on top of a house that it absorbs heat and then runs water through it and then puts that water into a tank, and it can be used both to heat a house through a radiant type flooring, or it can be used through in junction with a natural gas or wood boiler to also heat the house or give hot water. We're seeing interest in solar thermal waning because of a lot of its cost and complexity from a plumbing standpoint, all the way to the fact that, if you overproduce hot water, your utility company will not pay your client for that. But if they overproduce electricity, depending on their agreements, they get paid for it. So overproducing hot water, unless you've got some sort of special setup with your community or your multifamily apartment where the hot water can go somewhere else, doesn't seem to work. The other thing to note is that the energy efficiency of appliances and heating and cooling systems are getting so efficient that you can use electric solar to offset them instead of solar thermal. So this is what we look at: PV, photovoltaics, made out of different substances, made out of different heavy metals, different types. We're not going to get into all the details here. There's all sorts of education out there on the different types of solar systems, but the basic concept of having a solar system in place. And one of the first things to note, too, is that you can first work with your client to design a renewable-ready home, is what they call them. So, maybe they find that solar PV just isn't cost-effective for them now, but the house, whether it's through a major renovation or a new construction, especially a new construction, can take advantage of pre-designing this so it's ready for plug-and-play instant solar. So what I mean is pre-wiring for solar and running the conduit up to the roof, having enough south and east facing roof space out there, and so that way, it's just ready to go, and avoiding shading as well, or having enough space on the property. And so, maybe in 2-3 years, the cost comes down, the client says, boom, let's put this on. And so that's another value add you can give to your client, or the concept of renewable or solar-ready homes. And we're going to be doing a session with the Department of Energy on their Zero Energy Ready Home program, which gives a lot of guidance and details on how to do that. So one thing you can do with a client is you can go to PV Watts Calculator if you're not working with a formal local solar designer. This is a really cool tool developed by the National Renewable Energy Laboratory. You can go in and drop the existing address or the proposed address, and then, well, I don't have the other picture here, but, what you can do for an existing or proposed address is you can actually get a Google Earth-like view, and you can draw out a shape, and then, you can put in a few other details that guide you through the system, and then outspits how much energy it thinks you can generate a year with a conventional system, just to give you and your client a starting point. And sometimes people use this to work backwards to say, okay, if I can generate this much on this lot, and I want to be like a zero energy home, then we have to work backwards from there on the energy efficiency. So just real quick, zero energy is the new buzzword. There's a lot of terms out there on what that means and how to achieve it, but we are seeing more and more people talking about it. So it's a buzzword, and it's something you definitely want to know, especially if you're working with eco-conscious clients. The first thing you have to do is follow the other aspects of the energy efficiency pyramid to get your loads down, and then from there, you want to design the appropriate renewable energy system to achieve that. So we have a program that can help with that called Zero Energy Capable. We also have some other great educational resources out there on case studies of people who have done zero energy and how they got there on new and existing homes, as well as just some basic concepts and rules you can follow to help your clients achieve their zero energy dreams and desires. So that concludes Module 2. And so now we're going to be getting into health. So for energy is usually what they call the gateway drug to green building. But once you've got your energy down, now you need to start looking at the health aspects of a home. And so we're going to be getting that into the next session. So thank you for joining us, and we'll see you there.